We discovered 511 vulnerabilities inside popular open source projects that were never publicly disclosed. In this video, I'm going to take you through some research that we did. I'll explain why this is such a problem, some concerning trends that we're seeing in the space, and also the role that AI and LLMs had to do in this. Before we get into it, I have a quick favor to ask. Like this video, subscribe to the channel. It helps the Google gods know that we're trying to make good content at least. All right, enough about that. Let's get into the research. At the start of this year, Aikido Security, we decided to put together a research team to try and find vulnerabilities inside popular open source packages. And one of the ways that we decided to do this was to utilize LLMs to actually sift through all of the different change logs and release notes of software to understand if a security vulnerability potentially had been patched or not. When it comes to our open source packages, they create about 85% of the source code that's in our application. So it's extremely important that we know what vulnerabilities we have in there. And the entire open source supply chain at the moment revolves around public disclosure of vulnerabilities. This is that either the maintainers or security researchers discover a vulnerability and they report it via a CVE, common weakness and exposures. And that is then put inside a vulnerability database like the NVD, National Vulnerability Database, or the MITRE CVE or the GitHub Advisory Database. And this is really important because this is pretty much one of the only ways that we know what the state of our open source supply chain is. We can check our projects and the packages and the version numbers against these databases and see, are they reported vulnerabilities? If there are no reported vulnerabilities, then the assumption is that these packages are safe to use. Sometimes, however, maintainers can do something called silent patching or shadow patching. And this is when they quietly fix a vulnerability but don't tell anyone about it. You might be thinking, well, if they fixed it, why does that really matter? Well, that would require you making sure that you're using the latest fixed version. And while it's a good practice to continuously patch your open source dependencies, there's a common saying that if it ain't broke, don't fix it. Well, and this can apply to software development. A lot of the time, we're not so eager to update our dependencies to the latest version immediately if everything's working fine. Updating them can break things, and if there's no vulnerabilities, we're not going to do it as urgently, or at least some people will. In our research, we looked at 5 million popular open source packages, and as I said, we used LLMs and trained them to be able to read these release notes. Now, the reason why we trained LLMs and why this was an important use case in this scenario is that often the release notes will indicate that a problem has been fixed, but not explicitly say it's a security. Of course, sometimes we'll get explicit examples like fixed RCE or fixed cross-site scripting, but most of the time we'll get something a little bit more ambiguous. This might be something like increased default work factor, or fixed polluted array prototype, safer checking for templates, or sanitizing the path name in the middleware. All of these kind of indicate that a bug or a security vulnerability has been fixed, but don't explicitly say it. So it'd be very hard to identify this through different methods other than using an LLM that can interpret that. We would then take all of these examples that the LLM model had given us. We would check them against the CVE databases to make sure that a vulnerability hasn't been reported. And then a human, one of our security researchers, would look into this, assign a severity for it, and make sure that they can recreate the problem. The human factor in this is really important. Because we're finding ambiguous problems, the LLM can't be trusted solely by itself to uncover and verify these. So we needed to make sure that we had security researchers that was looking into this. We then created our own little threat feed or threat database, if you will, called Aikido Intel. And in here, we publish all the results that we have. You can check it out for yourself, intel.aikido.dev. And we also have an RSS feed that you can subscribe to. We continuously check our database and see if CVEs have been updated. And this is where we got some pretty concerning trends. One of the first assumptions that we made is that potentially the reason why there's no CVE is that there is a lag between when a problem is found and fixed and a CVE being assigned to it. That is quite dangerous, but that was the assumption that we were going on. However, we discovered that 67% of all the vulnerabilities that we found never got an associated CVE number. They were never publicly reported. Obviously, some of the lower severity vulnerabilities, this happened more to. 92% of low severity vulnerabilities were never reported. But both high and critical were above 50% of never being reported. And that's kind of scary. And these aren't unpopular projects. For example, Axios, a promise-based HTTP client for the browser in Node.js, it has 56 million weekly downloads. And in January, we discovered a prototype pollution vulnerability that was high, and it was never publicly reported. To this day, at the recording of this, there is no CVE available for this project. Some other examples are Apache eCharts, which was a interactive charting and data visualization library, had a cross-site scripting vulnerability in it. 1 million weekly downloads, was never reported. Or another one was the StatMix CMS, which is a core level CMS composer package, 2 million downloads, a critical path traversal vulnerability, and no public disclosure. So why would someone fix a security vulnerability and not disclose it? Well, there's quite a few reasons. They're not all that malicious. Sometimes you might be worried about the reputational damage of your package. No one really wants a CVE next to it, so perhaps you're trying to sweep it under the rug. Maybe you believe that just because you fixed it, it's not a problem, so you can get away with this. Sometimes it is actually just a lag between finding a vulnerability and having it publicly reported. The longest time between this that we saw was 9 months from a vulnerability being fixed and a CVE being assigned to it. But this doesn't mean that the maintainers did it. It also could be independent security researchers that found it later on. And one of the final and probably most likely scenarios of why these vulnerabilities are never reported is because open source maintainers are stretched pretty thin. They have a really important job that they're out there doing, often thanklessly maintaining these projects and having to report vulnerabilities, and often having to deal with security policies, report the CVEs, and everything can just be too much. So this video isn't about trying to shame these maintainers. It's just more about saying, hey, this is a real problem and we need to try and find a solution for it. I am happy to say that we are actively going to be reporting these issues that we find to the big vulnerability databases to make sure that everyone does have coverage now that the research component is over. But this certainly shows some interesting and concerning trends that we're seeing out there in the open source world. If you want to make sure that your open source packages don't have vulnerabilities within them, then you can sign up for free for Aikido. We do some great software composition analysis that will understand if you have vulnerabilities, including any of the ones that have been fixed but not publicly reported that we just talked about. I hope you found this video useful. Make sure you subscribe to the channel. We've been doing some great research that I can't wait to share with you in the future. So until then, I hope you have a great day, great week, and a great year.